So power versus root. When we talk about power, we know it's a degree. It's also called an exponential or exponent raised to the root. We got a square root, cube root, so on. So let's use the example that I have this radicand with some root with a radicand as a p or a and raised to p power. So I'm going to break it down just a little bit further. A is my radicand. If it's written to a format that it's broke down as far as it'll be broke down, we also call it a base. My n is going to be called the index, meaning what root is it? You know, what root? Square root, cube root, square, cube, fourth, fifth, dot, dot, dot. The p is my power, so it's whatever it's raised to. Sometimes it's just 1. And this thing here is called the radical. By definition, I can rewrite this as my radicand raised to the power of p divided by the power of the index. So I have my power over my root. Based upon this, we can solve a lot of problems, but we need to understand the if statements. So if the p is greater than the n, so if the power is bigger than the index, so let's use an example of the square root of 27. We know that 27 is 3 times 9. We can rewrite that, since it's multiplication, as the square root of 3 times the square root of 9. Some of you already know the answer because we know what square root of 9 is. But I want to go back, just go back one step to where I say, let's look at this here. I have the square root of 3 times 9, which 9 is this 3 times 3. This is my prime factorization. So if I rewrite this, I'll end up as 3 cubed, right, in exponent form. So by definition, this is 3 raised to 3 divided by 2, because that's the square root, right? My power over my root. So I have 3 halves. So this goes back to where my p is greater than my n. If this is happening, then you can factor out all or some of the radicand, which we call it the base sometimes, depends on if it's broke down good enough. So let's rewrite this. I'm going to come back to here. I have square root of 27. We know it's the same as 3 times 9, which is 3 times 3 squared. So this 3 is raised to the first power. It's getting left behind. So this statement here goes to, if p is less than n, leave alone. So that one there is going to be left behind. There's nothing we can do about it. If you put it in the calculator, you get some decimal and it's ugly looking. And this one here, though, my power is equal to my index, so we're left with the radicand. So it's going to be times 3. But I always encourage you to put your whatever's not inside the root in front of it, just so you don't accidentally put it in the root. So there's my if statements. If my power is greater than my index, we know that something, if not all, is going to factor out. If my power here is less than my index, which my power here is a 1, right? And it is less than 2, so we leave it alone. If my power is equal to my index, which my power here is 2 and my index is 2, then we're left with the radicand and everything else drops off, leaving me with 3. And then I'm going to rewrite it where it's neater, and I have 3 square root of 3. And that's it.